My name's Mark Fleiner. I'm the chief executive of a company called LG Fuel Cell Systems. And basically my normal responsibilities are overseeing all the operations for a group of people that work here in Canton. I've got a team in Derby in England, about 2 hours north of London, and a small research group in Seoul, Korea. And what I do is I run this business for my two shareholders. One of them's LG out of Korea, and one of them is Rolls-Royce out of England, not the car company, the engine company. I've been working in and around the energy industry my entire career. So, kind of places like GE and Rolls-Royce, now LG, Micron, and pretty much my career has been in the sales, marketing, business development, kind of strategy aspects of all the business operations. So our primary market today are utilities. Okay, so if you think of the traditional utilities, the traditional energy companies, AEP, First Energy, Duke Energy, those are kind of the big three in Ohio. They're under a situation now where they're being forced to retire some of their coal power plants by the EPA. The Environmental Protection Agency is forcing them under the Clean Power Plan to retire these coal plants. So they're looking at these coal plants that are big, kind of 1,000 megawatt, coal plants by scale. Our sort of building block is 1 megawatt. So we're 1,000th of a big coal plant. But a big coal plant has to be located far away from cities. You have to build big transmission lines, distribution lines to get the power to where it's needed. So we're developing a fuel cell that ultimately goes in a fuel cell system. So a fuel cell, in the simplest sense, is basically a device that takes a fuel and air, and instead of putting those through like a combustion engine or a gas turbine, where you burn fuel and air to make heat, to make something move, to make energy, you actually chemically react the hydrogen out of the fuel and the oxygen out of the air. So it's kind of power through chemistry. And the benefit of that is it's much more efficient than burning fuel. It's got a much lower carbon footprint, and so from an overall environmental aspect, it's much friendlier than kind of combustion engines or gas turbines. I guess if you had to compare it to something, it operates like a big central power plant, like a coal burning or nuclear powered power plant, but you can place these systems anywhere you want, adjacent to a building, in the middle of a university campus, next to a hospital. Utilities can put them on the grid somewhere. So any place where you need electricity, you can kind of put these things down. Whether it's a gas turbine or a steam turbine, a big coal power plant, or a gas engine or a diesel engine, what you're doing is you're still taking fuel and air, and you're putting them into an environment where you're burning them, right? You're actually combusting fuel and air to make heat. As you look at that whole process, there's a lot of inefficiencies in burning the fuel and then making something spin to make electrical energy. So in our case, what you do is you basically take fuel and air, and you basically have separate streams of fuel and air, and you take the hydrogen out of the fuel, the oxygen out of the air, the ions, and you chemically react them. So and then that chemical reaction produces a DC voltage. So you don't have any of that wasted energy that you do when you combust fuel and air. And the byproduct of these things is essentially it's steam, so kind of hot water, really hot water, and a little bit of CO2, but much lower CO2 footprint than you get out of a gas engine or a gas turbine, because you're converting more energy out of the fuel than you do with conventional technologies. And that's where you get the low environmental impact and the low carbon footprint, if that makes any sense. There are no parts that come out at a maintenance cycle that are environmentally, you can landfill them. Okay, so you don't have to incinerate them or do any special environmental handling of any of the parts. With wind, it's a great technology, but when the wind doesn't blow, it's not making any power. Solar is great, but if the sun isn't shining, or it's nighttime, or you get clouds that come over, you can literally see the output of a solar panel dip, and then the cloud clears and comes back up. Dip, comes back up. So if you've got a facility or process that needs a consistent supply of power, you need something that has a base load type capability. And our system basically has that. You turn it on and it makes power. So you're using natural gas, right, and you're using air. As long as you have a continuous supply of natural gas, you can keep making power. You don't need the wind to blow or the sun to shine. Even though we're burning natural gas, so a lot of people think, natural gas, it's a carbon fuel, it's really not renewable. Well, when you're talking about the high efficiency and the versatility of the system in an application, there's a lot of benefits there. And as I said earlier, I'm a huge fan of wind and solar, but the fact of the matter is when the wind isn't blowing and the sun isn't shining, those things are not producing electricity. If I had to describe simply the business today, we're very much a kind of research and development and testing business. And we're transitioning from that to one that's about to work on our product solution that will eventually go into the market as a commercially viable power system. Our current plan today sort of has us with a commercial product in the field sort of around 2018. If you really want to think about it, an industry that has a lot of interesting future to it, the energy industry. I mean, you look at what's happening with natural gas and oil, all the different types of power generation, the whole electrical system, the natural gas infrastructure, hydraulic fracking, all these different technologies and solutions in the evolution of the energy industry. I think there's all kinds of opportunity. And it doesn't matter if you're an engineer, it doesn't matter if you're a finance person, it doesn't matter if you're a geologist. I mean, geologists, you gotta look in the ground to find where the reserves are. I mean, there's all kinds of opportunities for students today in and around the energy industry.